All right, here are solutions for today's log rules worksheet that we did in class. Before I started the solutions, I went ahead and wrote up a bunch of different log rules. I refer to these top three as the three log rules, and then here's your change of base formula, and then a couple of, I don't know, I call them identities just so I have a different name for them as opposed to log rules down here. So I'll be referring to these throughout the video. So in part one, it asks what whole number are the expressions below equal to. I think most of them are really whole numbers. I might have screwed up one or two, but we'll see as we go through it. This first one, you got the log base 6 of 4 plus the log base 6 of 9. You stare at this thing, and if you try to figure out what the log base 6 of 4 is, you'll struggle. At least without a calculator, you'll struggle, because it's not obvious what power you raise 6 to make it equal to a 4. So you don't know what number this is equal to. So you might think you're stuck since you don't know what that number is equal to, but in fact you're not. You can apply our first log rule. In reverse, if you want to think about it that way, what I have is something that looks like this. Playing the role of b is 6, x is 4, and y is 9. So I can rewrite this. I can say this is the log base 6 of 9 times 4, which ends up being 36. And the log base 6 of 36 is 2, because the power that I need to raise 6 to make it a 36 is just 2. For the next one here, you'd like to use one of your log rules, maybe this first log rule in reverse with this plus here, but you can't because of the coefficients. So you take care of the coefficients with this third log rule. You take this negative 1/2 that's out in front, and you can make that the log base 3 of 4 raised up to the negative 1/2 power. And similarly, you can take this 2 that's out in front to make this the log base 3 of 6 to the second power minus log base 3 of 2. I didn't leave myself a ton of room, but we'll see if we can make this work. 4 to the negative 1/2 power. Well, the negative in negative 1/2 means take the reciprocal of it. So this is the same as 1 divided by 4 to the 1/2 power. And 4 to the 1/2 power is the square root of 4, which is 2. So this is equal to 1/2. And 6 squared is just 36. So that takes me here. And now what I can do, I don't know if you want to do this in one step or two steps. I guess I'll show two because I'm still early on in the worksheet. I'll go a little bit quicker as I get going. Is I'm going to apply my first log rule on these first two terms, leaving this one alone. So I'm going to say I have the log base 3 of, and then 1/2 times 36, this is using this first rule in reverse, is 18. And then from that I want to subtract the log base 3 of 2. On log base 3 of 18 minus log base 3 of 2, well, I can now use my second log rule here, again in reverse, I guess, if you want to think about it that way. And 18 divided by 2 is 9, and the log base 3 of 9, well, that's just equal to 2, because the power that I have to raise 3 to make it equal to 9 is 2. All right, this mess here, same kind of idea. I'm going to take the coefficients out in front. Maybe I'll start over here for this one. So I'm going to rewrite this as the log of 16 to the 1/2 power plus the log of 5 squared divided by the log of 1,000 minus 1. Well, let's see, 6 to the 1/2 power is the same as the square root of 16, and that's just 4. So really what I have here is log 4 plus log 25 divided by log of 1,000 minus 1. And log 4 plus log 25, using my first log rule here, I can multiply the 4 and the 25 to get that that's the log of 100 divided by the log of 1,000 minus 1. And the log of 100, when you don't write a base, it implies base 10. So this is asking me to what power must I raise 10 to make it 100? Well, 10 squared is 100, so it's equal to 2. Similarly, 10 to the third power is 1,000, so the log of 1,000 is just equal to 3. And 3 minus 1 is 2, and 2 divided by 2 is just 1. So I guess my final answer for this guy here would just be 1. Maybe that helps. Okay, down here, we've got a bunch of composition here, so be careful. We're not multiplying here. It's not natural log times something. It's natural log of the log of 20 of the log base 2 of 4 to the 10th power. Kind of said that right. I think the easiest way to do this, you can do this however you want, I guess, is let's first find the log base 2 of 4 to the 10th power. And don't figure that out by figuring out what is 4 to the 10th power. It's some absurdly huge numbers, like, I don't know, millions or so. Instead, use your third log rule. Right? You take exponents and bring them down in front. So if I bring that 10 down in front, I get that this is 10 times the log base 2 of 4. And the log base 2 of 4, that's asking me the question, to what power must I raise 2 to make it a 4? We got to square it, so it's the second power. So I get that's 10 times 2, aka 20. So now that I have that, I don't know, maybe with an arrow. Oh, I'm actually down here, so I don't need to pop back up. So now what I have is this is the natural log of the log base 20 of, and then instead of log base 2 of 4 to the 10th power, well, I figured out that's 20, so I can just throw a 20 in right here. Okay, so what is the log base 20 of 20? Well, that's asking me what power do I have to raise 22 to make it to 20. 20 to the first power is 20. So log base 2 of 20 is just 1. And the natural log of 1 is 0. Again, this is asking me the question, to what power must I raise? And there's an implied e here when you have the natural log. E is a number that's about 2.718. And e to the 0 power, like any other number, except for 0, to the 0 power equals 1. So my answer, all this work, is just 0. So I guess from here I went over there. All right, this mess, kind of similar to some we've seen. Up on the top, I have this 1/3 here. And I guess I'll keep showing this. I can use my third log rule to bring that up into the exponent. And similarly, I can use that same rule to bring this 3 up in the exponent. So now I have the log of the cubed root of 50 cubed. Wait a minute, the cubed root of something cubed, don't that just cancel out? Yep. Down on the bottom here, I got 1 plus the log of, I'm going to take this negative here, there's a couple ways you can do this, and kind of think about it as a negative 1. So I'm going to think about this as though it were 1 over e to the negative 1 power. A lot of parentheses. And the reason I'm going to do that will be more clear in the next step, so let me keep going. If you go through and simplify this mess, 8 to the 1/3 power is asking you what's the cubed root of 8. And the answer to that is just 2. And like I talked about before, the cubed root and the cubed here cancel each other out. So I get that that whole thing is just the log of 50. And down on the bottom, I got 1 plus the log of, and then 1 over e to the negative 1 power is just e. And the natural log of e is just 1. Should I show another step there? Yeah. So I'm just going to rewrite 1 over e to the negative 1 power as e, because that's what it's equal to. And then in the next step, I'll change this natural log of e into the 1 that it's equal to. All right, so now I can start simplifying stuff, maybe right here. Up on the top, I got the log of 2 plus the log of 50, and using this first log rule kind of in reverse, I can rewrite that as the log of 2 times 50, which ends up just being 100. In the denominator, I have 1 plus the log of, and instead of writing natural log of e, I can just write the number 1, because the natural log of e is 1, because the natural log of e is asking me the question, to what power must I raise e to make it an e? The answer is 1. The log of 100, remember there's an implied 10 here. 10 squared is 100, so the log of 100 is 2. The log of 1 is asking you to what power must you raise 10 to make it 1? The answer to that question is 0. So I guess 2 over 1 plus 0, aka 2. That's the answer to E there. All right, what about F? That's what I'm on, right? Yeah. Where to even begin with this guy? The natural log of 1 is just 0. I don't even have to worry about that. The natural log of 1 is asking you to what power must you raise e to make it 1, and I feel like we've seen that before. Maybe, maybe not. That's just 0. You can bring this 3 up into the exponent if you like. I prefer to bring this negative 3 up into the exponent, so I kind of like to write this as 0 plus the log base 6 of 2 to the negative third power. You could also make it 0 minus log base 6 of 2 to the third power. Either way is fine. Plus, this 2 right here, I give you a little hint, write it as a product instead of a quotient. What are you talking about? What I'm talking about is you could rewrite that as 1/2 times the log base 6 of 4. This negative 2, again, I kind of like bringing the negative up into the exponent, but if you want, you can just bring the 2 up into the exponent, whatever makes you happy. But I'm going to bring the negative 2 up into the exponent and call this the log base 6 of 3 to the negative 2 power. Since I brought the negative up, this becomes positive here. Kind of showed too many steps because these are all ready to go and this one's not, but it's okay, I can deal with this. Let's see, the log base 6 of 2 to the negative third power is, well, 2 to the negative third power is the same as 1 over 2 to the third power, which is 1 over 8. I can take this 1/2 and bring it up into the exponent, so I got log base 6 of 4 to the 1/2 power. Well, 4 to the 1/2 power is just 2. And then I got the log base 6 of 3 to the negative second power. So that is the log base 6 of this 1 over 3 squared, which is 1/9. Now if I jam everything together, really I'm using this rule twice. I got that this is the log base 6 of 1/8 times 2 times 1/9, aka 2 over 72. aka 1 over 36. The log base 6 of 1 over 36 is asking you what power do you raise 6 to make it 1 over 36? Well, to get the 1 over part, I want a negative exponent. To get the 36 part, I want a 2. So that answer is negative 2. This mess. Okay. So the trick with this, I don't know that you'd recognize to do this immediately, but I've done this problem enough that I kind of know how to do it, is this log 3 and this log 3, those guys are going to kind of pair up. So I'm going to take the log base 3 of the natural log of, maybe I'll take this 54 and bring it down in front first. So I got the log base 3 of, and then I'm staring at this natural log of 512 to the 54th power. Well, I know I can take the 54 down in front of that log, the natural log. So I got 54 times the natural log of 512. Close up my parentheses, I'm left there. I'm going to write this one next because later on I'm going to want to put those together. So I got minus log base 3 of the natural log of 2. And then I have plus log base 3 of 1/2. And then I have this mess, plus the natural log of e. Well, the natural log of e is 1, and the natural log of 1 is just 0, so that's going to end up going away pretty soon, but tackle that later. And then here I have my third log rule. I have an exponent that I can bring down in front, that 11. And then the log base, whatever that is, I'm pretty sure those are the same number. So I'm not even going to bother writing it. That's just equal to 1. So I get here. Okay, now what I'm going to try to do is put these two guys together. So I have the log base 3 of something minus the log base 3 of something else. Actually, that's not true. That's not what I'm going to do. I'm going to first break this one up. I'm going to use my first log rule. It says when I have the log of something times something else, I can rewrite that as the log base 3 of 54 plus the log base 3 of the natural log of 512. And then from that, I want to subtract the log base 3 of the natural log of 2. And to that, I want to add the log base 3 of 1/2. And then to that, I'm going to add 0 and 11. Where do I go? I don't know. I guess right below it is as good as anywhere. I'm going to put these two guys together. So this and this give me the log base 3 of the natural log of 512 divided by natural log of 2. So that is my second log rule going on there. What about you forgot about the log base 3 of 54? No, I didn't. I got this log base 3 of 54 and this log base 3 of 1/2 that I'm going to put together using my first log rule. So putting those together, I get the log base 3 of 54 times 1/2, which ends up being 27. So I get to here. From here is probably the hardest trick. The natural log of 512 over the natural log of 2. What the hell are you going to do with that? Oh, that's my second log rule. No, it's not. If you had the log of something divided by something, it would be your second log rule. But we have two natural logs in here. This is actually the change of base formula hidden in here in reverse. If you're in my class, don't let that freak you out. I would never, I guess I've done it in the past. I would not put this on a quiz or a test. At any rate, the natural log of 512 over the natural log of 2 can be rewritten as the log base 2 of 512. The log base 2 of 512 can be rewritten as any log I want of 512 divided by that same log of 2, which is what I have over here. Log base 3 of 27, that's asking you what power do you got to raise 3 to make it a 27. That answers 3. So I get here. The log base 2 of 512, I don't know, count that on your fingers or something. How many 2's do you get to 512 if you're multiplying them? 2, 4, 8, 16, 32, 64, 128, 256, 512. I think that was 9 that I counted out there. Log base 3 of 9 is 2, because 3 to the second power equals 9. 2 plus 3 plus 11 is equal to 16, which is the answer to this ridiculous problem. Guess I'll end this here and do the second page in another video.